I think it'd be funny that's like right in the middle of.
Yeah.
Okay, so we're gonna start talking about geometric series or geometric sequences first. The things that's different about geometric sequences is that they don't have a common difference, they have a common ratio. Someone raise your hand and tell me what is a ratio. Raise your hand and tell me. Yes.
Something compared to something else. Like,
what does it look like? What is
it's
it?
like number,
colon,
colon,
number.
What hand?
Number, colon, number.
Okay. What's another way to express a ratio? Fraction.
Yeah.
What operation is going on with the fraction?
division.
So if things have a common ratio, you can, so, with arithmetic, how do we say we found the common difference? Like a sure way to always find the common difference. How do you find the common difference of this sequence?
Subtract.
What from what?
You could well you can add or subtract. But no, you can't add. You can add 2 times. You can subtract. You can subtract.
We know by looking at it.
7 from the 5 from the 7.
What's D equal to? What's D?
2.
We know it's 2. So how can we find a positive 2?
You can subtract. Add 1 and 3.
You add 1 and 3?
No, because then you get 4.
Oh.
Subtract.
Subtract one term minus the one right before it. And that's how we found common difference. So one term minus its consecutive. So 3 minus 1, 5 minus 3, 7 minus 5. Since all those are 2, we know it's arithmetic. With geometric sequences, our D is now going to be an R for ratio. We want to find a common ratio. Do you see a pattern in this sequence?
What did we say about
Multiples of 3.
Yep. Oh,
Is this an
3
arithmetic
times 2.
sequence?
you multiply by 3 every time.
Is it arithmetic?
No.
3 minus 1 is 2. 6 minus 3 is 3. 9 minus 6 is 5. So it's not arithmetic. To find a common ratio, you divide the pattern would be just be root to the end. Root to the 0, 3 to the first, and 3 times 2. Yeah, this is a bad example. Alright, find a common ratio, we divide one number by the one right before it.
Wait a minute. What?
So in this sequence, it's not arithmetic, but there is a pattern that's going on that we can notice.
Multiply by 3.
So to find this, if it was somewhat confused, this is a really simple example. You would divide 1 by the one right before it. Like, yeah, you multiply by 3, but the common ratio is not 3. I mean, it's not 3 times that. Because 3 times this is just 1. If we divide 1 divided by 1/3, we'll have our common ratio. If we divide 3 by 1, we'll have a common ratio. 9 divided by 3. So 1 divided by 1/3 is the same thing as 1 times 3 over 1, which is 3.
Wait, hold on.
So, does that hold true for this whole sequence?
Let's see, what do they mean right there? They just wrote.
Okay. Remember the common difference of the arithmetic sequence was just the difference of one term minus the one right before it. Well, with the ratio, common ratio is one term divided by the one right before it. So if we look at this sequence, we want to find a common ratio. We look at the second term, then we divide it by the one right before it. So 1 divided by 1/3. When you divide by a fraction, you multiply by the reciprocal. So 1 divided by 1/3 is 1 times 3 over 1.
Okay.
And that equals 3. So we want to look at the second term, or the third term now. 3 divided by 1. Is that the same thing we got here?
Yeah.
Is it true for the rest of them?
Yeah.
9 divided by 3.
3.
27 divided by 9.
3.
81 divided by 27.
30.
So these all have a common ratio of 3. They're being multiplied times 3 each time.